A Gothic cathedral, it doesn't follow the logic of its own time. These are stone mountains, built without a single page of calculus, without a flicker of computer code. That's the central puzzle. You have to understand the hidden language, ropes, templates, intuition. That's what made these miracles possible. A simple piece of cord could draft a building that touches the sky. And some of their most brilliant features, they look perfectly imperfect. We're walking the same tracing floors as the master masons, uncovering a forgotten form of genius. True innovation, what does it look like when you have to build it by hand? That language of ropes and templates, it wasn't just a technical choice, it was spiritual. For the master mason, a circle drawn in the dust wasn't just a shape, it was a glimpse of the cosmos. That's the key to them. Geometry was the handwriting of the divine. The fundamental blueprint of creation, a perfect, eternal order that human hands could try to replicate. Building a cathedral wasn't an engineering project. It was a devotional act. The architect wasn't just solving a load-bearing puzzle. He was composing a hymn in stone. Every decision, from the grand vault to a single carved leaf, was guided by that belief. Their tools were simple, but the vision behind them was cosmic. Think of the basic shapes, the circle representing the heavens, eternal, no beginning or end. The square for the earth, its 4 directions, and the triangle, often the divine trinity. These weren't arbitrary symbols, they were a sacred alphabet. By combining these perfect forms, the Masons believed they were building a miniature universe, a microcosm mirroring God's macrocosm. That's why proportion was everything. The width of the nave might relate to the ceiling height through a sacred ratio, like the golden section, thought to be inherently pleasing because it reflected divine harmony. A window's tracery wasn't just decoration. Its intersecting circles and arcs were a meditation on unity, the interconnectedness of all things. This philosophical foundation gave them something modern blueprints can't. A unifying, timeless framework. For centuries, across different sites and generations, the core principles stayed constant because they were rooted in faith, not fashion or whim. A mason from France could look at a wall in England and understand its geometric logic. They spoke the same sacred language. That shared belief system allowed for such breathtaking consistency and ambition across Europe. Long before standardized measurements or global communication, they didn't need complex algebra to calculate beauty or meaning. The meaning was built into the geometry itself. The act of building became a form of prayer, a physical dialogue with the divine. So when we look up at those soaring vaults, we're not just seeing an architectural triumph. We're witnessing a frozen theology, a belief made manifest in limestone and light. That spiritual drive set the stage, but it had to meet the stubborn reality of gravity and stone. How do you translate a divine circle into a standing building? The answer isn't in the heavens. It's in the humble tracing house on the ground. The floor of the tracing house held the sacred geometry. But the real drawing board was the construction site itself. Their first tool, the most important one, was incredibly basic. Just a strong cord and some sharpened wooden pegs. This was the master mason's blueprint. Before any foundation stone was set, he'd go out onto the leveled ground. His canvas was the earth. This process was called setting out. He'd drive a central peg into the packed dirt, tie the cord to it, stretch it taut and walk a perfect circle, scratching a line with another peg or a piece of chalk. That one action established the proportional heart of the whole cathedral. The nave's width, the columns, the sweep of the apse, all of it could be generated from that first circle. Through a series of geometric operations using just that cord, it was full-scale drafting. There were no small paper plans to get wrong. the stonecutters and layers saw the actual size of every arch and vault drawn right there on the ground. This method bypassed complex mathematics. It relied on a deep understanding of geometric truth, a knowledge held in the hands and the mind. By swinging an arc or creating a perfect right angle with a 3-4-5 triangle of knotted cord, the mason wasn't calculating. He was revealing, making the invisible logic of the sacred forms visible and permanent. Every line scratched in that dirt was a direct translation, a spiritual principle becoming a physical instruction. The cord was more than a tool. It was a bridge between the ideal world of divine geometry and the gritty reality of the quarry. That cord in the dirt, it was just a start. You could wipe it away with a foot or a bit of rain. To make something that would stand for 1,000 years, they had to lock that geometry in place. To turn a circle in the soil into a perfect stone arch, what they used was a simple object, a wooden template. Picture a carpenter up on the windy cathedral scaffold. He's holding a thick piece of oak, on it the exact profile of a crucial stone, maybe the curve of a vault rib or the complex shape of a window's tracery. This wasn't a rough guide, it was a precision tool carved and sanded to perfection. This template became the law for the stonecutters down in the yard. A mason would set it right on a rough limestone block, trace the outline with a metal scribe, then carve away everything that wasn't that shape. What you got was a stone that wasn't just like the one next to it. It was a perfect match. Every piece of a Gothic window with all its intersecting bars came from a set of these wooden patterns, so when the pieces were hauled up and slotted into place, high above they fit. Like a three-dimensional puzzle, no one needed to calculate angles up there. The precision was already in the stone, baked in at the moment it was cut, guided by that piece of oak. But the real power of this system was how it moved. A master template wasn't kept in one place, it was portable knowledge. This is where the mason guilds made the difference. The skilled craftsmen were nomadic. They moved from one great building site to another, all across Europe. A master mason who perfected a window template at Chartres might carry that knowledge to Cologne. Or to Prague. He didn't bring a book of formulas, he brought the shape itself. This spread of physical knowledge created a consistent visual language. It moved across the continent like a slow wave. A mason from England could show up at a site in Spain and understand the assembly because he recognized the families of shapes. It meant a new idea didn't stay local. If someone in France designed a stronger flying buttress, that improvement was carried in the form of a new wooden pattern. To the next town, to the next kingdom, this was a shared language built not on paper but in pine and oak. It showed a community could achieve incredible uniformity, technical excellence without a single governing theory. Without a central academy, they didn't have a unified math, they had something else, a library of shapes, a craftsman's trust in the template, and a guild network that turned one person's insight into a common inheritance. The stone spoke the same language because the hands that shaped it all used the same alphabet. But for all that brilliant organization, the cathedrals have a secret. They aren't the perfect, rigid machines this system might suggest. You look closer and you see the human hand in all its glorious, compensating imperfection. Look at the walls, they seem impossibly thin for the weight they're holding. How do they stand? The mason didn't have a stress formula, he had a shape. The square, from that one trusted shape, he could generate the entire cathedral's proportions. It was a system of ratios born from trial and error, locked into geometry. Here's how it worked. You need to determine the height of your nave vault. First, you establish the width of the nave as a square on the tracing floor. Then you take the diagonal of that square. That diagonal line, swinging up in an arc, gives you the height of the vault's peak. One simple operation. The width and the height are now linked by the geometry of the square root of 2. That ratio repeats across the building. The same logic, using triangles or other derivatives of the square, could set the thickness of a wall, the spacing of columns, the projection of a buttress. These weren't arbitrary numbers, they were a family of relationships, a self-consistent language. This system did something. It created structures that were inherently self-bracing. The forces flowing down from the vaults and out through the flying buttresses weren't an accident. They were choreographed by these preset proportions. The mason, by following the rule of the square or the equilateral triangle, was channeling lines of force along the strongest geometric paths. The diagonal of a square is a natural line of thrust. By building that line into the bones of the structure, they made the building want to stand. Stability by design, not by calculation. This knowledge wasn't in a textbook. It was carried in the hands and the eyes. A master taught his apprentice not with equations, but by pointing to a wall that had stood for 100 years. See that proportion, that's the one we use. The apprentice learned by replicating the successful shapes, internalizing the feel of good geometry. It was a living library of what worked. A cathedral was less an individual invention and more a collective memory built in stone. Each generation added refinements, but the core proportional wisdom remained. They were building on a mountain of silent, successful experiments. So when we marvel at the fragility of those walls, we're not seeing a gamble, we're seeing the confidence of a craft. A deep, inherited understanding that if you follow the sacred shapes, the building will hold. It's a faith placed not in unseen numbers, but in visible, timeless geometry. That trust in proportion solved the puzzle of height, but it created another challenge. How do you crown this stone mountain with something that feels like it's made of light? That trust in proportion fixed the problem of height, but it introduced another one. How do you keep a mountain of stone from falling over? The answer is right there on the outside of the cathedrals. The flying buttress, that stone skeleton, looks like a pure engineering calculation, but how it came about was more human. It was a story of desperation. Of watching walls crack, of learning from the mistake. Gothic builders had made a trade. They swapped solid walls for huge windows of glass. They pushed the vaults higher. But a stone roof has tremendous weight. It doesn't just press down, it pushes out, like someone trying to force their elbows outward. All that outward thrust, with no thick wall to hold it, meant the building's own ambition could rip it apart. And that happened. Early attempts at height led to cracks, to collapses. They were hitting the physical limit of the material. They needed a new kind of wall. One that could be there and not there at the same time. The answer didn't come from theory. It came slowly from watching and adapting. Someone had a simple, physical thought. What if we catch that push before it breaks the wall? What if we build a prop outside? They began with small, hidden supports. Then they got bolder. They pulled the support away from the wall entirely, connecting it with a stone arch that seemed to jump through the air. That was the flying buttress. It wasn't decoration, it was a structural tool. Its job was direct, catch the roof's outward push at the high wall, channel it down the slope of the arch. Dump it into a huge stone pier in the ground. The wall was free now. It could become a thin screen of glass because the hard work of holding up the roof happened outside in that stone skeleton. This was engineering by feel, by trial and by serious error. A master mason couldn't calculate the force, but he could see a crack. He could build a buttress, watch how the building settled, and then, years later, the next mason might change the angle, adjust the weight, make it a bit more efficient. It was a conversation over centuries between human ambition and the stubbornness of stone. Each cathedral was a workshop. A buttress at Chartres taught something they used at Reims. A change at Amiens showed up at Cologne. This knowledge wasn't in books, it was in the stance of the buildings. You can see the learning in the stone. Early buttresses are thick, careful. Later ones become thinner, more confident, as the mason's gut understanding of the forces got deeper. They were learning the language of push and counter-push by speaking it. By building it, by seeing what stood and what fell. The flying buttress is the purest record of that method. Its structural instinct made from limestone. A physical answer to a visible problem honed by generations of hands-on work. It turned a weakness, the wish for taller, lighter walls, into the great, stunning strength of the whole era. With this stone skeleton bracing the walls, the builders could aim for their real goal. Not just to build high, but to build a space that felt like it had no weight at all. A stone frame designed to vanish. The stone skeleton handled the vaults, but the master mason was looking past the earth. He was looking toward the heavens. To line up his building with the cosmos, he used a different tool, one that measured the sky, the Astrolabe. It was this intricate brass instrument, the most sophisticated computer of the medieval world. A learned cleric or a traveling scholar could use it to tell time, to map stars, and for the builder to find true north, to track the sun's exact path across the sky. This wasn't for navigating a ship, it was for navigating the soul. The cathedral had to be oriented. Its long axis from the west door to the high altar in the east needed perfect alignment. The Astrolabe made that possible with astonishing accuracy. This was long before magnetic compasses were reliable. They would sight the North Star or measure the sun's shadow at its highest point. That established a true east-west line, the sacred axis. This mattered because a cathedral was a clock and light was its hand. The alignment meant that on the most important day of the church's calendar, often the feast day of the cathedral's saint, the dawn would perform a miracle. As the sun rose, its first rays would pour through the eastern windows. They would travel down the long, shadowy nave, a river of gold piercing the gloom. To strike the high altar at the exact moment of morning mass, it was a choreographed spectacle, light over darkness, a symbolic reenactment of creation, of resurrection, played out in architecture and light. That required a deep, practical understanding of solar cycles. They needed to know not just where the sun was today, but where it would be on a specific date years in the future, once the building was finished. The Astrolabe held that knowledge. Its complex web of lines, the retere, modeled the celestial sphere. By turning it, they could simulate the sun's journey for any day of the year. This integration of astronomy was a holistic genius. Sacred timing, symbolic meaning, and physical construction all converged into a single experience. They achieved a sophisticated result, a building that told time and told a story without a single trigonometric table. They used a physical model of the sky to orient a model of heaven on earth. The light wasn't an accident. It was the final, glorious member of the building team. The Astrolabe aligned the cathedral with the cosmos, but the real breakthrough in its form was in a single, simple curve. You look at a Gothic window, its silhouette, it doesn't end in a gentle half-circle. It comes to a point. That's the secret, the pointed arch. It wasn't chosen just for its beauty, though it does reach upward. It was a quiet structural revolution. To see why, you have to feel the weight. Think of a traditional rounded arch, a Romanesque arch. It's like a stone rainbow. All that weight up top pushes down, but it also pushes out, forcefully at its sides. It's trying to flatten itself, that outward thrust. It demands thick, heavy walls to contain it. Like a barrel holding its staves together, the pointed arch behaves differently. Its geometry is sharper, more decisive. It channels the load from above down along its sides. In a more vertical path, it's a funnel for force. That simple change dramatically reduced the outward push. The walls no longer had to be massive buttresses themselves. They could become thinner, they could become windows. That was the key that unlocked everything. Taller naves because the piers could carry weight more efficiently. Vast walls of stained glass because the structure wasn't relying on solid stone for strength anymore. The pointed arch turned the building from a fortress of mass into a cage of force. A skeleton where every bone was aligned to carry a specific load. The masons likely discovered this not through complex math, but through physical models. They'd build small arches out of wooden blocks or even stacked stones. They could feel the difference. They could see how a rounded arch wanted to spread, and how a pointed one stood more firmly. It was knowledge gained by hand, by eye, by testing the behavior of shapes in the real world. This intuitive understanding of force management changed architecture. Once they had this modular key, they could combine it. Two pointed arches crossing each other created the ribbed vault, a lightweight stone web that could span incredible distances. The arch became a building block, repeat it, intersect it, and you could generate the most complex ceiling forests, all from that one intelligent curve. It shows a profound truth about their innovation. They weren't calculating stress vectors. They were reading the language of weight and support, written in stone itself. They found a shape that told gravity a new story, and that story let the walls dissolve into colored light. The pointed arch gave them a new language for the ceiling. But the real change came when they started weaving those arches together. You think of the earliest stone ceilings, the groin vaults. They were just two barrel vaults crossing at a right angle. It worked, but it was heavy, it was dark. The Gothic builders looked at that intersection and they saw a line of potential strength right along that crossing seam. So they built that line first. They carved a slender rib of stone, an arch, and set it along that groin. That rib became the permanent spine, and suddenly, the heavy infill stone between the ribs, it didn't have to be structural anymore. It could be thinner, lighter. The rib carried the load. That was the leap. They weren't just building a ceiling, they were building a skeleton for the ceiling. A permanent stone scaffold that defined the shape from the start. Once they had that system, the possibilities opened up. You could design the ribs on the tracing floor. Two pointed arches crossing in the center. That was a simple four-part vault. But then you add a third rib, or a fifth. By adding more intersecting ribs, you could create stars. Webs, fans of stone that seemed to bloom from the columns. These elaborate patterns, like the fan vaults later on, they look impossibly complex, but they're built on the same modular principle. Each individual rib is just a simple arch drawn with a cord and a peg. The complexity comes from the intersection, the meeting of many simple parts. It's a three-dimensional puzzle solved in 2 dimensions on the tracing house floor, and this meant they could vault spaces that weren't simple rectangles. A curved apse, an odd-shaped chapel bay, these weren't problems anymore. You just adapted the rib pattern to fit the plan. The ribs gave order to chaos. They turned the ceiling from a massive, monolithic slab into a lightweight, geometric tapestry. And because the ribs were built first, the masons working high on the scaffolding always had a guide. They would slot the thin stone panels, the webbing, into the waiting arms of the ribs. It was a foolproof system. The ceiling you walk beneath is actually a record of its own construction. First the ribs defining the space, then the infill locking it into place. This method shows their deepest insight. They understood that overwhelming complexity could be mastered through modular, repeatable simplicity. A breathtaking net vault isn't a single carved object. It's a family of identical ribs arranged by a strict geometric rule. They made the ceiling feel organic, like stone lacework, by using the most disciplined, logical process imaginable. The vaults are where the medieval mind shows its full power, not in calculating but in composing, building a universe of light and stone from a library of simple, sacred lines. The ribs up on the scaffolding, they were a guide, but the real design that happened down below, in a protected space, the tracing floor, it was like the cathedral's secret workshop. A large, flat area of plaster or sometimes smooth stone slabs, set up in a dedicated room or under a temporary shelter, and the master mason, he didn't work with small sketches there. He drew at the actual size of the building, life-sized, so an entire window, every bar of its tracery, scratched into that pale plaster surface, a full arch spanning 20 feet, outlined right there on the floor. This was their tool for precision. It turned geometry into something physical, a walkable blueprint. The process was direct. Using his chords, his wooden straightedges, his compasses, the mason would inscribe the key lines. He might start with a circle, then, through a series of moves swinging arcs, finding intersections, the pattern of a rose window would emerge. Every curve, every intersection point at 1-to-1 scale. That method eliminated a huge source of error. No mathematical scaling, no risk of misreading a tiny drawing when carving a massive stone. A stonecutter could walk into the tracing house, see the exact shape he needed to make. He could even place a wooden template directly over the lines on the floor to get a perfect copy. It was a shared reference, something everyone on site could understand. Collaboration was built into the floor. Different craftsmen could overlay their work, checking how a stone window frame would meet the lead of the glass, or how a sculpted column would fit into the arch above. Problems were solved in plaster, not in expensive stone 70 feet in the air. This shows something about their thinking. They thought in full scale. Their design process was never fully abstract. It remained physically engaged, visually verifiable. A mistake on the tracing floor was just a line you could rub out. A mistake in carved limestone was a disaster, so they perfected the design here first. In this forgiving medium, the floor itself became a living document. Older lines visible beneath newer ones, a palimpsest of the building's evolution. You can picture the master mason pacing the lines, seeing the future vault hover just above his feet. He wasn't just calculating, he was walking the geometry, feeling the space it would create. That scale model, thinking aloud for incredible complexity. The most bewildering star vault, the most flowing tracery, could be broken down into a sequence of simple moves, compass and straightedge, executed at full size. The tracing floor was where sacred geometry became a construction manual, a direct bridge between an idea and the hands that would build it. And on that floor, amid the scratched circles and arcs, they solved their final great puzzle. Not of structure, but of story, how to make the stone itself speak. The tracing floor held the master's design, but the master held something more valuable. Knowledge. In a world without engineering textbooks, how did this craft survive? It wasn't in a library. It was in a brotherhood, the Masons' Guild, a closed society. A craft union, a university of stone. Knowledge here wasn't written down. It was a guarded treasure, passed from hand to hand, mind to mind. These were the mysteries of the craft. Not magic, hard-won rules, the perfect ratio for mortar that lasts centuries, the exact moment to quarry stone so it seasons right, the geometric trick to lay out a spiral staircase so every step is level. This was know-how, not know-why. An apprentice learned by standing next to a master for years, watching how he held his mallet, listening to the sound of the chisel on good limestone, lifting the wooden template again and again until its shape was burned into memory. The learning was total, physical, slow. It created an understanding no blueprint could give. You learn the feel of stability, the sight of a wall about to bear weight. This tradition was oral, demonstrative. It created a continuous thread. A single master might work on 2 or 3 cathedrals in his life. His best apprentice would take his methods, his templates to the next great project. An innovation in one city, a stronger joint, a more elegant window would travel with that mason. It would be tested, adapted, improved at the next site. This was peer review on a monumental scale. The proving ground was the building itself. A faulty technique would reveal itself in a crack. In a collapse, that failure became a story, a warning passed down in the lodge. Do not build a buttress at that angle. Remember what happened at Beauvais. Successes were celebrated, replicated. Failures were studied, remembered. They became part of the guild's collective caution. This process, over generations, distilled a robust body of knowledge. Experience codified into tradition. The geometric rules scratched on the tracing floor weren't arbitrary. They were the survivors, the shapes and proportions that had proven, through centuries of trial and immense error, that they would stand. The guild system meant every cathedral wasn't a solitary experiment. It was the latest chapter in a long conversation, a careful conversation, conducted in stone, and whispered from master to apprentice on scaffolds high above the world. There was this final secret, passed down from master to apprentice, a kind of beautiful contradiction. The cathedrals we see as perfect, they aren't, not in precise measurement. Their lines aren't rigidly straight. The columns don't stand in flawless rows. And this was by design, a brilliant design. The master masons understood something. A building that's geometrically perfect on the tracing floor, it can look distorted to the human eye. It can look weak. To create that feeling of soaring perfection, they had to cheat. They had to bend the rules. Take the great central columns. If you built them perfectly straight, 100 feet high, an optical illusion happens. From the ground, they'd appear to bend inward, to waver. So the masons did the opposite. They built the columns to lean outward, just a fraction, and from below, that subtle outward lean cancels the illusion. The columns appear straight, majestically straight. This practice is called intosses, and it was applied to horizontal lines too. A long, perfectly level floor can appear to sag. So they built it with a gentle upward curve, imperceptible. The eye reads it as flat. The entire building was tuned for one viewpoint, the perspective of a person entering the west door, looking down the nave toward the altar. Every line was adjusted for that journey. The side aisles might be slightly narrower at the far end. That makes the nave seem longer. The vaults might be a touch higher over the altar. Drawing the gaze upward, this was their ultimate calculus, not the cold mathematics of the compass, the warm mathematics of human perception. They were building an experience. Not just a structure, the goal was spiritual awe, not geometric approval. They knew truth, for the person standing there was felt, not measured. A perfectly straight line could feel wrong. A carefully calculated curve could feel right, divinely right. This shows the depth of their artistry, masters of both stone and soul. They manipulated physical reality for a metaphysical effect. Light, space, proportion, choreographed to guide emotion, to make the vast feel intimate, the heavy feel weightless, the human feel connected to something infinite. In those intentional imperfections, you see the final layer of their genius. They weren't just answering to gravity and geometry. They were answering to the human heart. And in doing that, they built something a purely mathematical approach never could. A perfect feeling, crafted from imperfect stone. That perfect feeling, it came from stone and shadow. But it needed more than genius. It needed an army. The vaults, the windows we see now, they weren't just designed. They had to be financed, organized. It was a logistical puzzle as hard as any geometry. The scale of it, a single cathedral could take 100 years, more. Generations would live and die without seeing it finished. This wasn't a project, it was a city's permanent ambition, and it demanded a river of silver, a mountain of stone, a web of human effort that stretched across the whole countryside. The money came from everywhere. The church was a foundation, but it was never enough. Bishops became fundraisers. They got donations from kings and nobles who saw it as a path to salvation. A display of power, but the real lifeblood came from the people, the townsfolk, the merchants, the guilds. They gave what they could. A wealthy merchant might fund an entire window. A baker's guild might pay for a statue of their saint. Even the poorest could give a few coins, believing it bought them a place in the heavenly city they were building. That created a kind of ownership. The cathedral wasn't imposed from above. It was built from within, stone by donated stone. It became the physical heart of the community's faith. With the money, the real work began. The logistics were staggering. Stone was quarried miles away. Getting a 20-ton block from the quarry to the site was a feat. They'd load it on a sled in winter, drag it over frozen ground, or float it down rivers on barges. Then the challenge was vertical. How do you lift that block 200 feet into the air? The answer was simple machines. The treadwheel crane, a giant wooden wheel turned by men walking inside it, that provided the muscle, systems of ropes and pulleys, teams singing work chants to coordinate. They guided the stones into place. The scaffolding was a temporary wooden city clinging to the walls, rebuilt as the structure rose. This effort created its own world. A cathedral site was a town of specialists, master masons, stonecutters, carvers, blacksmiths, glassmakers, hundreds of laborers. They lived and worked together, often in lodges right next to the site. Knowledge was transferred on the job. An apprentice learned geometry by laying out stones. He learned physics by feeling the balance of a block in a sling. The site was a living university of craft. That stable, decades-long platform was the foundation. It allowed for the slow experimentation. A master could propose a new vault design, test it in a small chapel. If it worked, scale it up for the main nave years later. The social organization, the funding, the logistics, the guilds, it provided the steady rhythm. The quiet heartbeat that let the architectural mind dream. Without that communal engine, the geometric genius would have remained just lines in the dust. To build a vision of heaven, you first have to build a very earthly, very human machine. The cathedral was a human machine, but it depended on a deeper truth. A sacred geometric idea means nothing if the walls aren't straight. For all that soaring ambition, the builders were anchored by two humble tools, the plumb bob and the water level. They were the guardians of stability, the silent referees making sure the stone followed the plan. The plumb bob was pure simplicity, a pointed lead weight on a long cord. You'd hold it against a newly built wall, and it showed you a fundamental truth, the line of gravity, that unwavering vertical. The mason would watch the cord. If it ran parallel to the wall's face, all was well. If it gaped away, the wall was leaning. It was an instant physical check, no calculation, just observation. And this was critical because a leaning pier over 100 feet tall would magnify its error. It would push the vaults out of alignment, threaten the whole delicate balance. The plumb bob gave a constant, real-time correction. Every few courses of stone, the masons would check. They could adjust the next layer, bring the wall back to true. It was a conversation with gravity, a way to make the invisible force of the earth visible, to build in harmony with it. But a building needs more than vertical truth. It needs a common horizon, a shared level across its entire sprawling footprint. That's where the water level did its quiet miracle, a long, straight wooden trough filled with water. The principle is ancient. Water, left undisturbed, finds a perfectly flat plane. Its surface is level, so a mason at one end of the nave and his partner 200 feet away at the other end could each look at the water in their shared trough. They'd mark a line on their respective piers at the exact height of the water's surface. Those two marks, separated by a vast distance, were guaranteed to be on the same horizontal plane. This let them establish a continuous level line all around the building's interior, the springing point for every arch, the base of every window, the seating for every vault rib. All aligned to this common datum. It meant that when the complex puzzle of stones came together high above, everything met as intended. The precision was astonishing. It enabled coordination across a site that was noisy, crowded, changing shape daily. It was a fixed reference in a world of movement. Together, these tools created a vital feedback loop. The tracing floor held the ideal geometry. The plumb bob and level constantly measured the physical reality against that ideal. They were the bridge between the sacred lines scratched in plaster and the tons of limestone rising into the sky. They allowed for correction, for adaptation to the quirks of the material, the settling of foundations, the slight warping of timber scaffolds. This constant checking and adjusting meant a project could survive its builders. A master mason could die, but the next master could pick up the plumb bob, consult the water level, and understand exactly where the building stood. He could continue with confidence. Knowing the foundational truths were still in place, the plumb bob and level weren't about innovation. They were about integrity. In a structure designed to touch the divine, they ensured it remained honestly, steadfastly connected to the earth. They guaranteed the hymn composed in geometry would be sung in stone, perfectly in tune. That feeling of perfection was a kind of language, and the walls were the pages. For most people back then who couldn't read, the cathedral was their library, their scripture, their encyclopedia, a Bible made of stone and glass. Every surface had meaning, from the big sculpture over the door down to the smallest carving on a column. The sculptors were translators. They took stories from scripture, lessons from animal books, the whole order of the cosmos, and turned it into pictures anyone could understand. So a pilgrim walking through the west door wasn't just going into a building. They were stepping into a sacred story, a story meant to be read starting from the bottom. The lowest parts showed the earthly world, the labors of each month, the zodiac, scenes from daily life and human folly. And as your eye moved up, the story moved up. Saints and prophets filled the middle levels, and at the very top, around the figure of Christ in majesty, you'd find the heavenly host. The architecture was the guide. Moving from the dark, carved portal into the bright, colored light of the nave, that was a physical metaphor, moving from a world of sin into a world of grace. This visual theology was planned. It wasn't an afterthought. The master mason and the master sculptor worked together. A column wasn't just a support, it was a pedestal for a saint. A capital wasn't just a transition, it was a canvas for a parable. And the gargoyles, those strange faces on the rain spouts, they weren't random. They often came from popular bestiaries, books of animals, real and mythical, each with a lesson. A lion could mean resurrection, a griffin, the two natures of Christ, a fox dressed as a priest warned about hypocrisy. These compelling faces had a purpose. They externalized inner fears, casting them out of the sacred space, literally channeling them away with the rainwater. They taught that evil was recognizable, that it could be defeated. The most powerful story was often saved for the west facade, facing the setting sun, the direction linked to the end of time. Above the main door, you'd usually find the Last Judgment. Christ the Judge sits enthroned, hands raised to show his wounds. To his right, the blessed are led to heaven. To his left, demons drag the damned into monstrous mouths that are hell. The message for someone entering was immediate. You are being watched, your choices matter. This place is your gateway, but it wasn't just about fear. It was about order and hope. The whole sculptural program mapped a universe where everything had its place, from the lowest beast to the highest angel, all under the architecture of God's plan. The integration of this art with the structure shows the genius of it. There was no separation between engineer and artist, between message and material. A flying buttress could end in a praying angel, so the structural skeleton was also a chorus of stone. A load-bearing column could be a prophet, so the support of the roof was also a support of faith. Every element served two purposes. It held the building up and it lifted the spirit up. It educated the mind and inspired the heart. In this stone encyclopedia, someone who couldn't read could see the deepest truths. They could see their own labors in the harvest scenes, their own struggles in the battling beasts, and their ultimate hope in the faces of the saints leading toward the light. The cathedral didn't just house belief, it performed it, a silent sermon written for the eyes. The stone walls were supposed to disappear. That was the whole point. The Gothic ambition was to replace stone with light, which meant you needed a new kind of wall made of glass, but a stained glass window is a structural problem. It's a wall, but it's made of thousands of fragile pieces. The solution was the lead, those strips of cast lead shaped like an H. You fit each piece of colored glass into that channel, then solder the joints. That makes a rigid panel, but the lead does more than hold it. It becomes a flexible grid. When the wind presses against that huge surface, the lead cames bend just slightly. They distribute the force. They keep one weak piece from breaking the whole thing. It's a material compromise, strong enough to be a barrier but pliant. It can breathe as the building settles over centuries. Now this fragile mosaic had to fit into a stone opening carved with absolute precision. That required tight collaboration. The master mason designed the stone tracery first. That gave the exact size and shape of the opening. He'd make a full-scale pattern on parchment or a board and give it to the glass workshop. The glass artists used that as their blueprint. They'd paint their scenes on large sheets of glass, fire them to fuse the paint, then cut the glass into shapes. Each piece was a fragment of the story, a fold in a robe, a leaf, the curve of a face. Once assembled into its lead matrix, the panel was finished, a piece of art and engineering. Then came the final test, hauling this heavy, inflexible panel up the scaffolding and slotting it into the stone frame. If the geometry was true and the glassmakers followed the template, it would fit. A perfect marriage of color and stone. The light that came through was transformed. Those vibrant reds from gold oxide, the deep blues from cobalt, the greens from copper. That wasn't just decoration, it was alchemy. Sunlight passing through this metallic filter became something else, a luminous, jewel-toned radiance flooding the interior. On a bright day, the stone columns and floors danced with pools of sapphire and ruby. The whole space felt submerged in a sacred, liquid light. This was the final dissolution of the wall. The structure didn't just frame the light, it became the source of it. The narrative in the glass, a biblical scene, a saint's life, was no longer a picture on a wall. It was an environment. You stood inside the story, bathed in its glow. They had engineered with light, using chemistry and craftsmanship to turn physics into theology. The window wasn't an opening in a wall anymore. It was the wall's highest purpose, a barrier that, instead of shutting the world out, transformed the very essence of the world coming in. The light was only part of it. The cathedral was an instrument. They shaped sound as carefully as they shaped stone. Without any acoustic equations, they built sonic environments. They turned simple chant into something else. They engineered for the ear that long, hard reverberation of a Gregorian melody. That wasn't an accident. It was built in. It was a feature of the place itself. You have to think about the materials. Everything was stone or plaster or glass, hard, reflective surfaces. Sound doesn't get absorbed, it bounces, it lingers. A single note from a monk would hit the wall, travel up the vault, and swirl around for seconds, blending with the next note and the next. That created a thick texture, a continuous sonic atmosphere. The slow, single lines of plainchant were perfect for this. The architecture gave the music a body. A resonant presence. It felt less like a performance and more like the building was singing. The specific shapes amplified this. Those soaring vaults weren't just for height. They were giant sound reflectors. The curved surfaces of a ribbed vault catch sound waves and scatter them. They fill the entire space, and the long, narrow plan of the nave, like a stone canyon, creates a long reverberation path. A spoken word from the altar could travel down that canyon, reflected and reinforced, reaching the back with clarity, with authority. They probably discovered this through experience. A master mason might notice how sound carried better in a finished chapel versus a wooden hall, how a rounded apse seemed to focus a preacher's voice. Over generations, they refined the shapes. They learned that certain proportions, already sacred for visual harmony, also produced a desirable acoustic. The trial and error of structure had an auditory side effect. A vault that stood strong also sang beautifully. This made the liturgy a multi-sensory immersion. You didn't just see the colored light, you were surrounded by the sound. It came from everywhere and nowhere. It had no single source. For a medieval worshipper, this was profound. The voice of the priest, the chant of the choir, it didn't seem to come from human throats alone. It was amplified by the architecture, sanctified by it. It felt like the voice of the building, the voice of the faith itself. The space became an active participant. The sound's long decay created a meditative quality. A timeless quality, one phrase hanging in the air as the next began, blurring the edges between moments into a continuous, holy present. This acoustic design shows a holistic understanding. Sacred space wasn't just a container for rituals. It was a tool to shape consciousness, to use physics, reflection, reverberation, resonance, to craft a feeling of transcendence. The cathedral was built to be played, and its music was the human spirit given immense form by stone. The stones didn't always sing, sometimes they groaned. Cracked, roared, that ambition to build higher, to let in more light. It kept pushing against the hard limits of the material, and sometimes the material pushed back. For every cathedral that's still standing, there were experiments that didn't survive their own daring. The records from that time are full of these events. A tower would sway in a storm and fall. A section of vaulting, stressed too far, would buckle and crash to the floor decades after it was built. These weren't just setbacks. They were the most expensive lessons, the most terrifying lessons a master mason could ever get, and they became the most critical data in the whole craft's slow, empirical journey toward understanding. The most famous of these lessons happened at the Cathedral of St. Peter of Beauvais. In the late 13th century, its builders took a breathtaking gamble. They'd construct a choir higher than any other in Christendom. It was a statement of supreme confidence. They used every advanced technique: slender piers, a forest of delicate ribs, aggressive flying buttresses. And for a while it worked. The choir was consecrated, a breathtaking cage of stone and glass that seemed to defy physics. Then, in 1284, the lesson arrived. A large section of the vaults, high above the altar, just gave way. Stone and timber scaffolding plummeted into the choir below. The reasons were probably a perfect storm of factors. The height was unprecedented, the piers maybe too slender, the buttress system not quite equal to the lateral thrust. The collapse was a monumental event. It echoed across Europe from one mason's lodge to another. This wasn't a secret. It was a shared trauma for the whole building community, and it forced a fundamental reassessment. The failure at Beauvais became a permanent cautionary tale about the absolute limits of verticality. It proved that sacred geometry had a breaking point, dictated by the weight of the stone itself. The response wasn't to abandon height, but to build smarter. At Beauvais itself, and at other sites after, masons developed more robust solutions. They added a second tier of flying buttresses, a double-decker system of support. They thickened piers at key stress points. They refined the shapes of arches to channel force more efficiently. Each adjustment was a direct answer to a visible, catastrophic problem. That's the hidden engine of Gothic evolution. It was driven as much by pragmatic response to disaster as by pure visionary ambition. A collapse was the ultimate, brutal feedback. It showed where a theoretical shape met a physical reality it couldn't bear, and that knowledge got encoded into the craft. It traveled through the guild network as a story. A warning, a new template for a stronger joint. The next generation of builders incorporated that hard-won wisdom. They stood on the shoulders of giants, yes, but also on the rubble of their predecessors' noble failures. Every soaring spire that still stands is a monument to both triumph and loss. It represents not just what they dreamed was possible, but what they learned was necessary to make that dream endure. The legacy of their greatest failures is written in the enduring strength of everything that came after. That knowledge, the physical knowledge held by the guild, it had to be translated. It had to become daily action. For the hundreds of craftsmen on the ground, the master's geometric vision, it had to become muscle memory, and their most constant companions weren't the astrolabe or the cord. They were two simpler things, the mason's square and the rule of thumb. The square is just an L-shaped tool, usually iron. Its purpose was absolute. To create a perfect right angle and to check for it. In a building held together by gravity and friction, a right angle isn't just neatness, it's integrity. If the cornerstones of a pier, the quoins, if they aren't square, the entire pier starts to twist as it rises. That twist magnifies, it throws vaults out of alignment. It compromises the whole delicate balance of thrust and counter-thrust. So at every stage, on every stone, the square was the final judge. A mason would hold it against a freshly set block. A sliver of daylight between the tool and the stone meant an error. It meant correction right then before the next course was laid. This relentless, simple verification. It built a cathedral one true angle at a time. It translated the sacred geometry from the tracing floor into the brute, honest reality of the wall. But how did a mason know how thick to make that wall in the first place? Or how to proportion a window? They didn't calculate it new each time. They relied on a second tool, an invisible one, the rule of thumb, and this wasn't a single rule. It was a whole library of them, short, memorable phrases. They packed generations of trial and error into a few words. A wall's thickness should be 1/3 its height. The height of an arch is twice its width. These weren't arbitrary. They were the distilled wisdom of what had worked, and critically, what had failed on sites for centuries. Proportional formulas born from experience, not theory. A master taught them to his apprentice as rhymes, as proverbs, easy to remember, impossible to forget. This was quality control encoded in language. It meant an ordinary stonecutter who might not understand the cosmic significance of the square root of 2, he could still execute work of breathtaking precision. He knew the rule, he followed the rule, and because every craftsman on site knew the same set of rules, the work harmonized. A window carved by one man would fit the wall built by another, because both were guided by the same customary proportions. This toolkit, the square and the rule, it turned abstract design into reliable, repeatable craft. It allowed the cathedral to be built not by a handful of geniuses, but by an army of skilled hands, all speaking the same practical language. The square guaranteed the correctness of the moment. The rule of thumb guaranteed the wisdom of the century, and together they built something that felt divinely ordered. Through the accumulation of perfectly ordinary, meticulously checked actions, that army of skilled hands all following the same rules, it didn't stay in one place. You see a cathedral in France, and then you see its cousins in England, in Germany, in Spain, a revolution without borders. A style born in a small region around Paris became the architectural language of all Europe in just a few generations. There was no king's decree, no central academy sending out blueprints. It was more organic than that, more powerful, a network of ideas moving at the speed of a walking man. The engine was mobility, the master mason was a traveler, his knowledge was his most valuable possession, and it was portable. A master who perfected the new rib vault at St. Denis might take that expertise to Chartres. His best apprentice years later might carry those techniques to Canterbury. They didn't bring books of theory, they carried it in their minds, in their hands. In the wooden templates, the full-scale drawings on parchment, the hard-won rules of thumb that created a living chain, an innovation in one town didn't stay local. It was tested, adapted, improved at the next site. A new design for a flying buttress proven stable in Reims would be replicated in Cologne, peer review on a continental scale. The proving ground was always the building itself, and pilgrimage routes became highways for inspiration. Thousands of people walked the roads to Santiago, to Rome, to Jerusalem. They passed through towns with these astonishing new buildings. A bishop from Italy, seeing the light of Sainte-Chapelle in Paris, would return home with a vision. He'd seek out a master mason who knew the style and commission his own version. The patrons were as mobile as the builders. They created the demand, bringing back not just relics but ideas. This network diffusion led to something, not rigid uniformity but a family of variations. The core principles were a shared language, the pointed arch, the rib vault, the pursuit of light, but each region spoke it with its own accent. In England, they developed the perpendicular style. It took the vertical lines of Gothic and made them emphatic. Vast grids of stone tracery, enormous windows that turned walls into curtains of glass. It felt orderly, structured, like a sublime cage of light. In the German lands, a style called Sondergothic emerged. Special Gothic, it embraced complexity, intricate detail. Vaults became fantastical star patterns, looping, fluid lines that seemed to ignore gravity. The emphasis was on overwhelming visual richness, a stone lacework that celebrated the virtuosity of the craft. These weren't deviations from a pure standard. They were conversations. The French model provided the grammar, but local traditions wrote the poetry. A mason in Prague used the same geometric toolkit as a mason in York. But the local stone, the climate, the patron's wishes, they shaped the final form. That's how a powerful idea takes root, not by being imposed from above, but by being adopted. Adapted, made local, it standardizes through practice, not decree. The network of traveling masters, exchanging templates and tales, spread the core technical knowledge widely. But the human hands in each place then made it their own. The result was a continent unified by a common vision, yet dazzlingly diverse in its expression. A shared dream built in 1,000 local dialects of stone. The network carried the dream, but the building was done with local hands, using local earth. Every cathedral is really a monument to its own geology. The stones tell a story of deep, practical knowledge. It's a story of intimate familiarity with the land's materials, not abstract design. The master mason's first decision wasn't about the height of a spire. It was about the quarry. He needed stone that could be carved and trusted. In northern France, that meant limestone, a sedimentary rock laid down in ancient seas. It was the perfect compromise, soft enough to be shaped when first quarried, yet it hardened over time in the air. That workability was crucial. It allowed for intricate tracery, delicate foliage, the flowing robes of statues, but it also had to bear immense weight. The mason learned to read the stone like a book. He knew which beds in the quarry yielded the strongest blocks, free of hidden flaws. He knew the seasonal rhythm. That stone cut in autumn, after a dry summer, was less likely to split from trapped moisture. This wasn't science as we know it. It was craft wisdom, earned through generations of watching, testing, and sometimes through tragic failure when a block gave way. The stone was only one part. To lock those perfect shapes together, they needed a glue. That was the mortar, and its recipe was among the most guarded secrets of the mason's lodge. This was where craft met alchemy. The base was lime, burned from the same limestone they built with, mixed with sand and water, but then came the mysteries. The additives, historical records and chemical analysis reveal surprising ingredients. Egg whites, animal blood, even beer. These weren't random. They were the result of centuries of experimentation. Egg white, rich in albumin, could act as a plasticizer. It made the mortar more workable, slowed its setting for finer adjustments. It might also improve its final strength. Beer, with its sugars, could affect the curing process. These organic additions show a profound, empirical understanding. They were manipulating the chemistry of their binder long before they had the words for the reactions. They knew what worked because they had tested it. They compared a wall bonded with plain mortar to one bonded with their special mix, and they saw which one stood firm against frost and settling after 100 winters. This material science was passed down orally. A master would teach his apprentice the proportions in the privacy of the lodge. It was proprietary knowledge, as valuable as any geometric template. And then there was iron, used not as a skeleton but as a surgical stitch. They employed it with remarkable restraint, forged into flat bars or cramps, often shaped like a double T. These were set into channels carved in adjoining stones, then sealed with molten lead to prevent rust. Their job was specific, to hold critical components in precise alignment. You'd find them at the peak of a great arch where the two sides met, or tying together the stones of a window's delicate tracery. The iron took the tension, the pull, that the mortar could not. It was a localized reinforcement, a targeted solution to a known point of weakness. This careful, minimal use shows their respect for the material. They knew iron could rust and expand, potentially splitting the stone it was meant to protect. So they used it only where absolutely necessary and took pains to seal it away from moisture. Every material had its purpose, understood through long observation. The longevity we see today is the final proof of their mastery. Those walls have endured not just because of brilliant geometry, but because of the quality of the very stuff they're made from. The mortar has often outlasted the stone itself, weathering into a hard, ceramic-like bond. This was chemistry perfected through patient, relentless trial. They didn't have laboratories. Their laboratory was the rising wall, the changing seasons, the passing century. Each cathedral became a long-term experiment. And the results are still standing, a testament to an alchemical pursuit that turned local earth, common lime, and everyday substances into a glue for the ages. But this mastery of the physical world always served a higher vision. The stones were cut, the mortar mixed to realize an idea that was, in its own way, just as carefully composed. An idea about perfect harmony expressed through number and sound. The stones and mortar were just the method. They were aiming at something human. Every decision, from where they got the stone to the last carved leaf, it all followed one goal. And the goal wasn't efficiency, it was emotion. These were machines for making ore. Their main material wasn't limestone, it was perception. The builders were psychologists of space. They knew that to shape belief, you had to shape feeling first, and they built that feeling with precision. You walk inside, and the first thing is your body reorients. Your eyes go up, they're pulled up those lines, the vertical lines, all the way to where the vault ribs meet, way up there, like stone fingers pointing. And in that moment you feel small, made small on purpose. Your daily worries, your sense of self, it all shrinks, faced with that grandeur, that order. That wasn't a mistake, that was the point. The architecture works to dissolve the ego gently. It tells you you're part of something vast, something beyond you. That feeling of being dwarfed, that was the first step. Humility, then wonder, then there's the light. It doesn't just fill the space, it changes it. You're not in sunlight, you're standing in colored light. Sapphire, ruby, emerald. It pools on the floor, it moves on the columns. This light feels alive. It has weight, it makes the air feel holy. They knew light changes mood, it changes your mind. The entrance is dim, mysterious. Then you move toward the altar and the color explodes. Radiant, walking the nave is moving from shadow into revelation. It's a physical metaphor, felt in your eyes. The space doesn't just tell a story. It makes you feel the story. The cold stone, the smell of wax and incense, how sound lingers. Every sense is part of it. And then the details, the carvings, they pull you the other way. The vaults make you feel small, but the capitals, the gargoyles, the leaves, they ask for close looking. They reward it. They create discovery. Even in this overwhelming whole, there's care in every small part. That balance is the genius. The huge scale gives you awe. The tiny scale gives you affection, curiosity. It makes the immense feel personal. It says the creator of this cares for the smallest leaf. You are dwarfed and yet you are seen. That psychological effect, that was their true north. Structural innovation served it. Money and logistics made it possible. The guilds kept the knowledge to do it. Their success over centuries isn't in an engineering book. It's in the silent gasp of a visitor, the pilgrim who walked for months and fell to their knees, not from tiredness but from a feeling too big for words. They built for that gasp. They solved weight and thrust not for efficiency but to make a vessel for transcendence. The cathedrals are proof that the most advanced technology can be invisible. It's the technology of the human heart mastered in stone, and in that mastery they answered a question we still ask. How do you build a door to something infinite? Their answer was to build a space that makes you feel in your bones that you're already at the threshold. The feeling of awe was their true north, but was it built on a guess? We have the tools now to answer that. Modern engineers with laser scanners and supercomputers have started to reverse engineer these stone mountains. They map every curve, every crack with millimeter precision. Then they feed that data into simulations, finite element analysis. It's a method that breaks a structure into millions of tiny pieces to model how stress flows through it. They are quantifying what the medieval master mason knew in his hands, and the results are a profound validation. The flying buttress, that stone skeleton, isn't just beautiful. The simulations show it's nearly optimal. It channels the roofs outward, thrust along the most efficient path possible, down into the ground. The ribbed vaults, those webs of stone, create a perfect distribution of weight. The ribs act like permanent scaffolding. They direct forces along predetermined, robust lines to the columns below. Even the proportional rules of thumb, like a wall's thickness being 1/3 its height, are now seen to contain generous safety margins. Intelligent ones, they built in a hidden resilience, an understanding of material limits that kept these structures standing through wars, through storms, through centuries of settlement. This modern analysis doesn't reduce the medieval achievement to luck. It elevates it. It shows that through relentless physical experimentation, through observing what stood and what fell over generations, they developed a form of applied mathematics. Their geometric manipulations on the tracing floor were their equations. Their full-scale templates and models were their supercomputers. They were solving complex structural problems through shape and proportion, achieving results that align astonishingly well with the principles of modern engineering theory. They didn't have the language of vectors and stress coefficients. They had the language of the circle, the square, and the pointed arch, and that language spoke truth, a truth about load and counterload, about stability and grace, that we can now translate into our own digital terms. The laser scan confirms the intuition. The stone was right all along. The stones were right, and now we can prove it. We don't have to measure with a cord anymore. Today you can capture a cathedral with a laser. A scanner sweeps the nave, sending out millions of beams. Each one bounces back, recording a point. The result is a point cloud. A digital ghost made from billions of coordinates. This model is so accurate it shows the lean of a column to the width of a hair. It shows the subtle sag of a 700-year-old arch, the gentle tilt of a wall as the ground shifted. We can see the cathedral not as a perfect idea, but as a living structure, one that's been in a slow conversation with gravity its entire life. This digital twin becomes a new kind of tracing floor, an immortal one. It lets us peel back time. By analyzing the scan, researchers can see the construction sequence. They can identify where work paused, maybe for a generation, by changes in the masonry. They can find the repair from a forgotten storm, a later buttress added to shore up a wall. The laser sees the history written in the stone's own slight movements, but the scan is just the start. With this precise digital skeleton, engineers can run experiments. Impossible ones. They use computational modeling, a virtual physics engine. They can apply the weight of the roof, the push of the wind, simulate an earthquake. The software shows in flowing colors how the forces travel. The red lines of high stress flow down the ribs, out along the flying buttresses, down into the massive piers. Just as the medieval masons intended, the model confirms their skeleton of stone is a masterpiece, efficient load distribution. It shows where the safety margins are generous and where they are surprisingly slim. These tools act as a time machine for intuition. They let us witness the decision-making. We can test what happens if you remove a single flying buttress in the simulation. The screen erupts in red warning zones. It shows exactly where the wall would crack. This gives us a profound appreciation for why each element is there. Nothing is merely decorative. Every arch, every rib has a job, a silent dance of force and counterforce. The digital analysis reveals the cathedrals as dynamic systems. They were designed not to be rigid but to settle, to adapt. The mortar joints could compress, the lead in the windows could flex, the whole building could breathe, shifting minutely as temperatures changed. As the ground settled, this inherent flexibility, this forgiveness, is a key part of their longevity. The modern models show the original design logic had this resilience baked in. The master masons understood their materials not as perfect but as cooperative. They built for a reality that included movement. Their geometry was robust enough to accommodate it. So when we stand in the nave today, we are not in a fragile relic. We are inside a system, one that's been successfully balancing itself, adjusting itself for 800 years. The laser and the computer don't diminish the medieval achievement. They translate it. They give us a new language to appreciate an old, deep wisdom. They show us the cathedral is not a puzzle we've solved. It's a conversation between earth and sky, one we are now finally learning to hear. The laser scan confirms the geometry. It works, but the real insight is in the method. The question is what this old craft offers a designer now, and it's not about copying arches, it's a way of thinking. In a time of digital perfection, the cathedral has a counterintuitive wisdom. The first lesson is in the tracing house. They designed at full scale. They walked the geometry. Today we can render a photorealistic building in minutes, but it's only on a screen. The medieval mason forced a confrontation with reality. By drawing a window life-sized, he had to feel its proportions. See its weight. That physical engagement caught problems no algorithm could. A line that looked elegant on a small sketch might feel clumsy when you had to pace its length. This insistence on one-to-one prototyping, on testing ideas in the real world before the final material, is a timeless principle. Before we build with carbon fiber and smart glass, we might still need a place to walk the lines. Then there's the knowledge held in the hands. The guild system was a slow, deep transfer of craft. An apprentice didn't learn from a manual. He learned by feeling the vibration of a chisel, by mixing mortar until its texture was just right. This embodied knowledge is something our efficiency-driven world often sidelines. We prioritize speed. We replace skilled judgment with standardized components. The cathedrals teach that some understanding cannot be digitized. It lives in the muscle memory of the craftsperson, in the subtle adjustments made on site, in the stories of what failed and what held. Sustainable design today faces a similar challenge. It's not just about specifying the right solar panel. It's about understanding how materials age together, how a building breathes in its local climate, knowledge that comes from long, attentive practice. We might need a new kind of apprenticeship, one that blends digital tools with tactile wisdom. Their greatest innovation was geometric simplicity. From a circle and a square, they generated worlds of complexity. They didn't need a supercomputer to optimize every gram of material. They had a kit of sacred parts, a modular system that was infinitely adaptable. This is a powerful model for today. Instead of algorithmically generating forms unique to every problem, what if we return to a simpler, robust vocabulary of shapes that are inherently efficient? Easy to fabricate, beautiful in their logic, the pointed arch was such a module. It solved a dozen problems with one intelligent curve. In seeking sustainable solutions, we might look for our own pointed arches. Simple, elegant principles that can be adapted locally, using local materials without demanding custom, energy-intensive engineering for every project. Finally, and most importantly, they designed for experience, not just structure. The cathedral was a machine for awe. Every decision served that emotional and spiritual goal. Modern design, for all its brilliance, can become obsessed with metrics, energy efficiency, cost per square foot, structural load. These are vital, but they are not the end. They are the means. The Gothic builders never lost sight of the end. The human standing in the nave, feeling small and then uplifted, surrounded by light and sound. Our sustainable cities and buildings must learn this lesson anew. A net-zero energy building is a technical triumph, but does it make the human spirit soar? Does it connect us to light, to community, to a sense of place? The cathedral reminds us that the highest purpose of design is to serve not just the body, but the soul. It calls for a dialogue, not a dictate, a conversation between the stubbornness of material, the clarity of form, and the depth of human need. In that ancient, silent conversation, we might just find the blueprint for a future that endures. Even with lasers and computers, the cathedrals keep their secrets. We can map every stone, but the mind of the mason, in that moment of creation, we can't map that. Some questions just hang there like dust in the light. They're quiet spaces, gaps. Take the fan vaults at King's College Chapel, those stone petals flowing into each other in these impossible curves. We know the principle, ribs and templates, but the exact sequence, how they laid those shapes out on a flat floor first, that's still debated, fiercely debated. Which geometric step came first, and how did they know for sure that when the pieces were assembled way up there, they'd create that seamless canopy? The templates are gone, the method is a ghost. We have the result, the magnificent result, but the choreography of the design, that's lost. Then there are the numbers. The dimensions, they whisper about sacred meaning. You find the golden section, these ratios, throughout the plans. But was it a code, a theological message in feet and inches? Or was it just their system, their rules of thumb, naturally producing something beautiful? Did the nave's width encode a verse? Did the spire's height point to a mystical number? Some researchers see a pattern. They say it's too deliberate. Others see a toolkit, a robust geometric toolkit doing its work. Without a written philosophy from the masters, we're left with the stones. The stones are testifying, but silently. The truth is probably a blend, a practical craft soaked in spiritual intention. The work resonates on many levels. So the numbers might have meant everything and nothing. They were the language for the builder and the believer, both at once. Maybe the biggest mystery isn't the stone. It's the society. How did they coordinate it? A project that took generations. We know about the guilds, the money, the basic logistics, but the human coordination, it staggers you. A master mason starts a design he'll never see finished. He trains apprentices who will outlive him. They work with hundreds of others, carvers, glaziers, smiths. Specialists. There were no Gantt charts, no progress reports by pigeon. The plan lived in the master's mind, on the tracing floor, in the shared culture of the craft. Communication was face-to-face, instruction was demonstration, and yet, over a century, the work continued, through wars, through plagues, changes in bishops. Shifts in fashion. The project adapted but kept its vision. That focus, that transmission of a complex idea across lifetimes, it's a miracle of social organization. We still don't fully comprehend it. It speaks to a shared purpose, a purpose so strong it could bind a community across generations. These unanswered questions, they're not failures. They're gifts. They mean the cathedrals aren't puzzles we've solved. They're conversations we're still having. Each mystery is an invitation. It challenges us. Our modern arrogance, we have physics, we have engineering, but we lack the living craft. We have digital models, but we can't sit in the tracing house. We can't watch the master draw with a cord. The secrets that died with the last medieval mason, they keep these buildings active. They keep them as partners. The buildings don't yield all their truths. They ask us across 800 years to look again, to think differently, to appreciate that some genius isn't translatable into data. It exists in the space between the compass line and the hand that draws it, in the unspoken understanding on a windy scaffold between a master and his apprentice. That's the final lesson, maybe. True mastery leaves a trace of the unknowable, a silent testament, something even time can't fully decipher. The cathedrals aren't relics of some forgotten science. They're the record of it. What we've been looking at is more than an architectural puzzle. It's a portrait of a civilization that reached for the sublime by weaving together faith, geometry, and a raw empirical genius. They didn't have our mathematics, but they had something else, a deep literacy in the language of pattern and proportion. They could read the laws of physics in a rope and a weight. They encoded that understanding not in equations, but in the grain of wooden templates, in the murmured rules of the Guild Lodge. Their tools were humble, but their vision was cosmic. To build a model of heaven, they first had to master the grammar of the earth. So these structures stand as something far greater than beautiful buildings. They're a testament to human collaboration, not collaboration in a single lifetime, but across generations, guided by a shared, unwavering vision. Thousands of hands and minds worked in concert. The master mason who drew the first circle in the dirt knew he would never stand under the finished vault. The glassmaker painting a saint's face knew his work would be judged by light he would never see. Yet they contributed to a story larger than themselves. That continuity of purpose, transmitted through craft and custom, that's perhaps their most profound achievement. It built more than stone, it built a legacy. So when we look up into those vaults today, we're not just seeing intricate stonework or brilliant glass. We're looking at the crystallized intelligence of the medieval mind, a mind that could hold sacred geometry and pragmatic craft in balance, that could solve for gravity with a pointed arch and for the soul with colored light. Theirs was a holistic genius. Every chisel stroke served both structure and symbol. They remind us that the greatest human creations come not from technology alone, but from a fusion. Belief, intuition, and hands-on wisdom.